In this video, we're going to go ahead and discuss the standard template library. This is a library that is part of the C++ standard. There are, in my opinion, better languages to learn about data structures with than C++, or better languages to use, period. But for the purposes of this course, this is what we use. And the standard template library contains implementations of a lot of common data structures and algorithms. We will review it, and then also we'll talk about how things are actually implemented in this video and later ones. So, let's start with the question of why do we study data structures? Well, some good examples of data structures would be a dictionary, where you look up something by a word and find its definition. Maps, where you find routes through things, and social networks, how we connect people throughout various social environments. Data structures are discussed as both mathematical or logical models, which are called abstract data types. They present the abstract view of the system. So when we talk about a dictionary or a set, okay, then there's the implementation, all the details of how a data structure is implemented. An ADT is a data type that separates the behavior from the implementation details of that behavior. Some examples are stacks, queues, lists, trees. These focus on the design of the model and not the implementation. They emphasize the structure and algorithms used and focus on what needs to be done and how not how to do it. So here's a good example of an ADT. Consider a car. The vast majority of cars drive the same way. You use a gas pedal, you use a brake, you use a steering wheel. However, under the hood, they could be gas-powered, diesel-powered, electric, and they're implemented completely differently. So the question is, what is the ADT? The ADT is the interface to the various tools. For the car, it's the steering wheel and the gas pedals, irrespective of what is implemented under the hood. They are defined indirectly in terms of operations to be performed. So, for example, a stack ADT, which you can think of as like a stack of plates, has the following operations. Pop, which removes the item at the top of the stack. Push, which adds an item, putting the ones below it beneath it. Top returns the value of the top of the stack. Empty determines if the stack is empty and creates a new stack. However, you don't know the first thing about how it's implemented. A data structure is a way to store and organize data in order to facilitate access and modifications. Basically, it helps you structure your data so that you can get to it easily. We're going to look at several different data structures so we can understand the strengths and weaknesses of each, so we'll be able to choose the right one for the task. We're going to use the standard template library. So, the standard template library has n algorithms and m containers, and therefore we'll have n times m implementations. And now we have also the iterators component, which tie the two together. So the standard template library consists of algorithms, iterators, and containers. The most important and common use of these two are iterators and containers. Containers are generic class templates for storing collections of data, which contain other objects. These are data structures. Iterators are smart pointers that provide operations for access and facilitate use of containers, and they provide an interface that is needed for STL algorithms to operate. Algorithms are generic function templates for operating on containers. Why do we want to use the STL? Well, code reuse. Why should we reinvent things? Efficiency. These things have been poured over, optimized, and they work with modern compilers. They're accurate and less buggy because they've been around forever. They produce readable code and reduced control flow. They're standardized. And number 6 is dubious, but a role model of writing a library. And they have a good overall knowledge of data structures and algorithms. So, here's some of the containers. We've got arrays, vectors, decks, lists, maps, multi-maps, sets, multi-sets, stacks, and queues, and priority queues. There are also what are known as container-like interfaces. Oftentimes, the one with stars are referred to as container adapters. Basically, they adapt other containers to provide a specific interface. Containers are implemented as template classes and include member functions that specify operations that can be applied to the elements stored in the data structures. There are some common member functions across all containers. There's a default constructor, copy constructor destructor, an empty method, max size, size operator, an equal operator, relational operators, begin, which returns an iterator, end, which also returns an iterator, rbegin, which returns an iterator to the end, and rn, which returns an iterator to the beginning, erase, and clear. Now, you'll notice some of these are not available in various data structures because they don't make sense, and we'll learn more about that as we learn more about data structures. A sequence in STL is defined by a pair of iterators, an iterator being a smart pointer into a data structure, remember, defining a half-open range. Meaning, begin returns an iterator to the first element, and returns an iterator to the element after the last element with a value. It doesn't point to any element. You can't read from or indirect contents of that. Elements can be of any type, but must supply at least a default constructor, a destructor, an assignment operator, and some compilers will require equal and less than and maybe greater than, or not equal or greater than. Also, if data members are pointers, copy constructors, and equal operators. Iterators are used to reference an element stored in a container. These allow for the accessing of information, including in a container. They provide interfaces so the desired operation can be performed on elements of a container, and they are a generalization of pointers. They can be dereferenced, and they can have arithmetic similar to pointers applied to them. There's no iterators for stacks, queues, and priority queues because, as we'll learn, that concept doesn't really make sense. The algorithms are a standard template library that provides over 70 generic functions. These include such things as locating elements, inserting elements, removing an element, modifying, comparing, sorting, and more. Almost all these algorithms use iterators to indicate the range of elements the algorithms will perform on. So, for example, random shuffle reorders all the elements in container. We give it a iterator for the beginning of the collection we want to sort, which is V, and an iterator for the end. We can find an iterator that begins between begin and end with a value of 7. And we could count the number of items that are odd between the begin and end. Note that here odd num is another function. And this is some of the basics of the STL. We will discuss more of these in detail in upcoming videos.